Homework 3.5, Rational Functions, Video 4. Homework due Wednesday, May 27th, 2020 at 11:59 p.m. There are no referred homework problems on here because this is going to be more about theory. In the next video, we'll work some examples and then I'll give you some correlating homework problems. So in the previous video, we looked at Desmos to try to deduce how to calculate the equation of a vertical asymptote for a rational function. And we almost had it down. It seemed to be the values that made the denominator equal to 0, but there was an exception where the vertical asymptote essentially collapsed into a hole in the graph. So let's talk about how to figure out the asymptotes and the holes in the graph. Suppose f of x equals a rational function, n of x over d of x, where n and d are both polynomials, n for numerator, d for denominator. Two things. Number one, if x equals c is a 0 of d of x, translation, if putting this number in the denominator gives you 0, but not n of x. In other words, plugging this number into the top does not give you 0. Then x equals c is a vertical asymptote of the graph of y equals f of x. In short, if a number makes the bottom 0 but not the top, there's your vertical asymptote. The problem arises when a number makes both sides equal to 0. Now, if you click view an example or help me solve this or read the book, it's going to tell you something that's not entirely true. What it will tell you is if a number makes both sides equal to 0, you get a hole in the graph. But that's not always true. It boils down to multiplicities. Recall that multiplicity is the power on a factor. So for example, if we said x plus 5 squared and we put that equal to 0 and solve it, we would get x equals negative 2, but x equals negative 5, but the multiplicity would be negative. The multiplicity would be 2 because that's the power of the factor. If a number is 0 of both the numerator and the denominator, so it makes both sides equal to 0, then you check the zero's multiplicities on the top and on the bottom. If the multiplicity is greater in the denominator, bigger power in the denominator, then x equals c is a vertical asymptote. Otherwise, there's a hole in the graph at x equals c. I'll give you an example. Let's say that we had a function that looked like this. F of x equals, in the top, x plus 5 to the first power, which normally wouldn't be written with the power or the parentheses. And in the denominator, x plus 1, and we also have x plus 5 to the negative, x plus 5 to the second power. To locate vertical asymptotes, you first look at the denominator and find its zeros. Easy if it's factored. For the factor of x plus 1, its 0 is x equals negative 1. That's the value that makes this factor equal to 0. Does this make the top equal to 0? No. So I don't care about its multiplicity. This is a vertical asymptote. Makes the bottom equal to 0, but not the top. But now look at the other factor in the denominator, x plus 5. Its 0 is negative 5. Its multiplicity is 2. But negative 5 is also a 0 on the top. And its multiplicity is 1. When a value is a 0 of both sides of the fraction, then it comes down to multiplicities. If the multiplicity is greater in the denominator, then it's a vertical asymptote. So as is, x equals 5 would be a vertical asymptote. However, what if the x plus 5 on the top was also squared, making its multiplicity 2? Is the multiplicity of negative 5 greater in the denominator now? No, it is not greater than it. 2 is not greater than 2. In that case, it would be a hole in the graph. And if I kept raising the power in the numerator, it would still be a hole in the graph because the multiplicity in the denominator would not be greater. So that's the whole story. And honestly, this last thing says it all without saying the top, because the multiplicity of negative 1 down here is 1, but up top is 0 because it's not even a factor. So if a number makes both sides of the fraction equal to 0, you look for you look at the denominator's multiplicity. You look at both multiplicities. If the denominator has the greater multiplicity, yes, you're a vertical asymptote. Otherwise, you're a hole in the graph. Now, let me tell you the capacity in which this will be in your homework. If there is a common 0 on both sides, based on the homework problems that I had to select from, they will both be multiplicity 1, which means it will be a hole in the graph. That's why this author says, if it makes both sides equal to 0, it's a hole. Well, that's because the only time, if the multiplicity of the 0 in the denominator is greater than the multiplicity of the 0 in the numerator, yeah, it's a vertical asymptote. Otherwise, it's a hole in the graph. So for your purposes, because of the simplicity of the homework questions, which I'm about to demonstrate in the next video, if a number makes both sides equal to 0, it's going to end up being a hole in the graph. I just didn't want to lie to you and tell you that that always makes it a hole in the graph.